Okay, so I'm looking at this quiz, Modular Exponent Towers. I have this massive exponent here, 41 to the 55th to the 92nd to the 51st to the 30th, mod 23. So we want to break this down and simplify it and get it into something manageable that can be solved. So we'll look at this on the board. Just want to write that in mod 23. Okay, so first step here is what we'll do. We want to reduce the base, the 41, and we can do that mod 23. So we'll just kind of want to just break it into pieces. It's kind of intimidating altogether. So 41 mod 23 is going to be, just looking for the remainder, divided by 23, so this is going to be equivalent to 18. And then next, what we'll do to start is we'll call this x. So we're saying this is equivalent to 8 to the x mod 23, just to save me a step of rewriting all that. So then what we want to do from here is we want to make this x manageable, but what we can do, you write this down. So we have 55. We'll break this out separate and look at 55 to the 92 to the 51 to the 30. And what you can do is you can use you can use Euler's totient function, or you could use Fermat's little theorem. It's the same thing. And let's just, the totient function, which is the number of elements that are, the number of integers that are relatively prime. And in the case of a prime, 23 is a prime, it's just that prime minus 1. And so let's look at, so what we can do is we can look at this exponent, our x, mod 22. So it's just Euler's generalization of Fermat's little theorem allows us to always look at the exponent mod the totient function. So it gives us a way to reduce these exponents. Now, so back to our problem here. If we want, we could start doing the same thing we did above, reducing the base, mod 22. This is just going to be 11. So we can have that 11 to the 92 to the 51 to the 30, mod 22. I forget to write, these are equivalent signs, so let me write it like that. Okay, so we have that reduced a little bit. But what we notice is we still got a huge exponent here. So what we can do is repeat the same thing again, just by finding the totient of 22. But 22 is not prime. So what we can do is we can use the formula. 22, by the way, is 2 times 11. And so what you can do is the formula, you can take 22, we have a factor of 2, and we have a factor of 11. So let's just calculate this. 1 minus a half is a half. 1 minus 1/11 is 10 over 11. And you'll notice that that cancels that and that cancels that. And we're just left with 10. So our totient of 22 is 10. So then we can bring down, got this exponent here, so let's just grab that again. And we're looking at this mod 10. So you kind of see how this is going. We can just kind of repeat the same steps over and over again, but it's going to simplify pretty quick. First, reducing the 92 mod 10 is just 2. The remainder of 92 divided by 10 is 2. And then, one thing I forgot to mention is doing this where you use the totient function, you need to assure, oh, I just violated the, made a mistake. So you need to know that the base and the mod are relatively prime. So here, 8 and 23 are relatively prime. But there's a problem here, because 11 and 22 are not relatively prime. So I need actually to backtrack. Okay, so we seem to be like in a little bit of a bind here, because we definitely need to reduce this exponent, but 11 and 22 are not relatively prime. What we can do is we can break this 22 into two separate equations. So what we'll do, let me write this like this. So we have 11, I'm going to call this piece y, just so I don't have to keep rewriting it. So we'll say 11 to the y, and this, like I said, is 2 times 11. So we'll break this into two equations. Basically heading for the Chinese remainder theorem. Okay, like that. And then we can look at these each separately. But, so the good thing with these, typically what you end up with is, it'll simplify nicely like this. 11 mod 11 is 0. So whatever we have here is going to be 0. So we don't really have to deal with that. In this equation, since it's mod 2, that's going to reduce to 1 to the y. Oop, I didn't mean to do that. Mod 2. But, 1 is always 1. And sorry, this is because the remainder from 11 divided by 2 is 1. But 1 to any power is 1, and 1 mod 2 is 1. So no matter what we do here, we get 1. So this is going to simplify things quite a bit. Then, now technically we need to use the Chinese remainder theorem, but what I'll do is when we have an example that's this simple, where we have 0 and 1, we can kind of just check the possible values, because we're looking for a number mod 22 that meets these criteria, that it's 0 mod 11 and it's 1 mod 2. So 1 mod 2 is actually just saying it's an odd number. And actually, so maybe let's just start with this. So the numbers that are 0 mod 11 mod 22, there's only two of them. So there's 0 and 11, right? You could keep, there's other numbers that are 0 mod 11, right? There's 22, 33, 44, etc. But as a reduced residue, that's not valid, that's not valid, that's not valid. So we only have two options. And 0 is actually even. 0 doesn't satisfy this. So all we have left with is 11. So what that tells us, so we're backing up to here where we were. We're saying that this whole thing is going to be equivalent to 11 mod 22. Because we're including this whole exponent in this. We didn't actually need to calculate that exponent, because we know that whatever this exponent is, it's going to be 0 mod 11. And whatever this exponent is, because it's going to be odd, it's going to be 1 mod 2. So we actually just skip that whole part, and we just reduce this all the way to 11. That's pretty messy, but this thing is 11. Whoops. 11. Whoa. Okay, now we're struggling. Anyway, so all we need to do now, we have everything we need. We just need to back substitute and get back to the original problem. So if we look, it's a good idea to label this nicely so you can go backwards easily. This whole thing was our x value that we found to be 11. So all we need to do is put 11 in right here, and we can solve it. So let's go, I'll bring this down to the bottom so we can finish it off. We have the 11 we just found, and we're looking for this mod 23. Now, this part can be pretty manual, just crunching the numbers, but we still have another trick we can do. At first it looks like you can't do anything else with it because, like we said before, the totient of 23 is 22, but our exponent 11 is below that, so we can't reduce it anymore. But what we can do is notice this little trick. If I can write that 8 equals 2 to the 3. And then we can plug that in over here. So we're saying this is 2 to the 3 to the 11th mod 23. But that's the same thing as just using exponent rules, multiplying that in. That's the same thing as 2 to the 33 mod 23. Then we can go back and we can use our totient function again that we already found, that phi of 23 is 22. Then we can reduce 33 mod 22. So let's just do that. But that's easy. That's just our remainder of 33 divided by 22, which is 11. So then let's just work with this. And we can reduce our 33 to 11, so we get 2 to the 11 mod 23. Whoops, that was messy. Okay, so now, I think now we've done everything we can do. Basically, we just have to kind of calculate this. And let's see, so I'm just going to kind of multiply this out. So what we got, we figured before that we know from earlier that 2 to the 3 equals 8, so maybe we'll start at that point. So we could say 2 to the 3 is 8, but if we square that, we get 64. 8 squared is 64. And I'm trying to think of the best way to go. So this is going to be the same thing as 2 to the 6th. Okay. Basically, I try to find a simplification and look for something that's going to help us. I know that 2 to the 5th is 32, and then mod 23, that's going to be 9. And then let's reduce this 64. So I'm going to actually reduce that. So 23 times 3 is 69, so 64 is actually going to be the same as negative 5. So then just to finish off, to get to 2 to 11, we can use 2 to the 6 times 2 to the 5 is 2 to the 11. So what we can do is we can multiply minus 5 from here times our 9, and that's minus 45. But we want this mod 23. And then just remember, what you can do is we can say this is saying a multiple of 23, like, so we could add any multiple of 23. So I'm going to add 2 times 23, and that's going to be 46 minus 45 equals 1. And that should be our answer. So let me check that over on the quiz. We're saying it's a 1. That's correct. So that was quite a bit of work, but you actually see that it does reduce pretty nice, especially when we had that whole thing reduced to 11, and then it reduces to 1. So that's how you do these. That's a pretty good example, actually. Kind of had a lot of the tricks in there. I'll provide a link to this quiz so you can do some of these practice problems. You got the different difficulty levels if you want to try them out. Whoops, go back. And then in the help, there's a little bit of information on the steps I used and some of the tricks that I took. So hope that helps.